In this demo, we are going to show how to do experimental model testing using VMAP. Out of the entire experiment, the part that we are going to show is how to perform data acquisition using VMAP. Now, the version of the software that we are using is 4.2. Right next to the PC on which VMAP software is running, there is an experimental setup which consists of a cantilever beam which is fixed at one end, and we excite the beam using a instrumented impact hammer. And there are accelerometers which are sensitive in 3 directions, which produce vibration signatures which are acquired in the PC using a data acquisition card. Both the hammer and sensor signals are acquired and stored in the PC. The first step would be to bring up the virtual prototype or the model of the cantilever beam on which we are going to perform the experiment. For that, let me bring up the model. So here there are 2 options. You can either bring in just the finite element model result files, which is not what we are interested in right now. Since we are going to do an experiment, let me focus on the part of this dialog box where we need to input the test model. These files, elist.list and nlist.list, are created using ANSYS. So this is a full-fledged CAD model of the cantilever beam. This is the virtual prototype which represents the physical cantilever beam, which is right next to this computer. Now, there are a few things we have to set up first before acquiring data. This is a hammer test, so between these 2 tabs I pick hammer. The stimulus is connected to channel 0. AI refers to analog input. The sensitivity of the hammer is 10 millivolt per Newton. We set the frequency ranges, trigger is automatically selected, and it's a CISO, single input, single output test. Say OK. Now, after setting the hammer specifications, we need to define the location on the beam where the sensor is mounted. It can be done simply by just clicking on the approximate location on the virtual prototype. We need to specify a few data about the sensor and the orientation of the sensor with respect to the beam. So this is a triaxis sensor, as I mentioned earlier. We pick this. TEDS is transducer electronic data sheet. So if there is a TEDS enabled sensor and a data acquisition card, VMAP can directly read the information about the sensor, such as sensitivity, which should be used in the post-processing. Now in this case it is checked, which is why sensitivity information, there is no option to enter it manually. If I uncheck it, I could go and change this, say 5, 5, 5, and I need to define the sensor orientation with respect to the beam. In this case, they are all X, Y, and Z are oriented same as X, Y, Z of the geometry. And sensor axis that is normal to the surface, you will have 3 options, X, Y, and Z. I picked Z, which is the case here. If I change that, I'll have to re-enter this. Say acquire data. Now a data acquisition window comes up. So you have stimulus signal here and response signal here, which is nothing but stimulus is hammer and response is accelerometer. So I click start. Impact signal and the response, can I accept it? FRF and coherence, X, Y, and Z, or you can pick all of them. Say accept. We have completed 1 trial. Right now that has been counted, so it's showing up as 2. So I'm going to start the second trial. That was the second hit. It's been registered. Now we can see that this window, which did not have any information with the completion of one trial, now you have some data here, which is nothing but coherence. It says, in very simple terms, the signal to noise ratio. I can accept this. Now we are ready to do a third trial, but I would just skip this here. If I want to quit data acquisition for the first point, I say exit. Now the nice thing is you get a marker here on the beam